is AP Calculus 6-6, Properties of Integrals. For all of these, we're talking about the integral from a to b of f of x d of x, where that represents the area under the curve on the closed interval a to b. And a has to be smaller than b. Your smaller number goes on the bottom, your larger number goes on the top. If they're flipped, if they're backwards, then there's a property to take care of that. For the first one, if you go from a to a and you have the integral of f of x d of x equals 0, well, if you think about that, no matter what that function is, let's just say it looks like this. Well, if I start at a and I end at a, do I have any area under the curve if I haven't moved? The answer is no. So if these are the same number, then the area under the curve is going to be 0 because you haven't moved anywhere. You just have a length. You don't have an area. So that's kind of common sense, but it's one of those things that you have to recognize because it will show up sometimes in some of these problems where you're just working with the properties. In the next one, if you have the integral from b to a f of x d of x, well, those have the a and b flipped or switched. Remember, a will always be smaller than b. So if you have the bigger number on the bottom and the smaller number on the top, then what you have to do to find the answer is flip those two so that the small number is on the bottom and the large number is on top. And when you do that, you have a negative in front. That's one of your properties. So it will change the sign of that function. And then the other two properties that we've learned earlier in this chapter still apply. If you have a constant in front of your function, that constant can still be brought out to the front. Sometimes that makes it easier to solve. And if you have two functions added or subtracted from each other, then you can separate those into two separate integrals because it might make it easier for you to solve. And then another property you need to be aware of, if a, b, and c are numbers where c is between a and b, if we have the integral from a to b of the function dx, if you have a to c of the function plus c to b of the function, then that would equal the total function. In other words, let's just say I have this curve, and this is a, this is b, and c is right here. Well, this portion, this area right here, would be the integral from a to c of the function. This integral right here would be the integral from c to b of the function. And you just need to understand that if you add this portion and this portion, you're going to end up with the integral from a to b of the whole thing. So it's a pretty simple concept, but that's written in symbols for you. So you know if you have a number in between two endpoints on your function, then the left portion plus the right portion will equal the whole thing. So here's how they are going to present these as examples. They're saying let f be continuous. If the integral from 0 to 2 of f of x dx equals -5, and the integral from 2 to 4 of f of x d of x equals 10, find the integral from 0 to 4 of f of x minus 1 dx. Well, first thing I notice here is that I could separate this into two different things. So that's what I'm going to do first. That's the integral from 0 to 4 of f of x dx minus the integral from 0 to 4 of 1 dx, or just dx. And then for this, I can break it up. This goes from 0 to 2, and then this goes from 2 to 4. 2 is between 0 and 4. So I can separate this out as going from 0 to 2 f of x dx plus going from 2 to 4 f of x dx. These two added together give me that portion. And then minus the integral from 0 to 4 of dx. So I know that the integral from 0 to 2 f of x dx is -5. So I can replace this with -5 plus the integral from 2 to 4 f of x dx is 10. So I'm going to add 10 minus, well, the integral of dx is just going to be x, and that's going from 0 to 4. So if I compute that integral, I've got negative 5 plus 10 is 5 minus, now to plug into this, I have 4 minus 0. So I have 5 minus 4, which is 1 for our final answer. Here they say given, the integral from 2 to 4 x cubed dx is 60. The integral from 2 to 4 of x dx is 6. And the integral from 2 to 4 of dx equals 2. Now when I look at these, I notice that all of these integrals go from 2 to 4. And one of them gives me x cubed, the other x, and the other dx. So I'm going to manipulate what they give me to try to force them to look like one of those so that I can solve it. For the first one, the integral from 4 to 2 of x dx. That is very similar to this. But instead of it going from 2 to 4, it goes from 4 to 2. That's one of our properties. We learned that if they are backwards, then we can flip them, make it 2 to 4, x dx, and when we flip these two things, we have to put a minus in front or a negative in front. So now this looks exactly the same as this. So I know the integral from 2 to 4 of x dx is 6. So this is 6, but it's going to be a negative because we ended up with a negative in front. For this one, the integral from 2 to 2 of x cubed dx, well, that's the same thing as this, except it's going from 2 to 2. What did we learn? If there is no space in between, we learned that that is just going to be a 0 because there is no movement there. There is no area. For this one, the integral goes from 2 to 4. It's got 4x dx. That is very similar to this one with x dx, but it's got a 4 in front. But my properties tell me that I can bring that 4 outside of the integral. And now this, the integral from 2 to 4 x dx, we know is equal to 6. So I just have 4 times 6, which is 24. Okay, for this one, I'm going to rewrite it. I've got two parts here, so I'm going to rewrite it and separate those two parts out. The integral from 2 to 4 of x dx minus the integral from 2 to 4 of 8 dx. And now this looks exactly like this. So we know the integral from 2 to 4 of x dx is 6. So that portion can be replaced with 6. For this one, it's very similar to this, but my 8 needs to be brought out front. If I bring the 8 out front, now this is the same as what I have here. So I've got 8 times 2. And so we have 6 minus 16, which is a negative 10. Here it says given the integral from 0 to 5 f of x dx equals 10 and the integral from 5 to 7 f of x dx equals 3. Find the integral from 0 to 7 f of x dx, the integral from 5 to 0 f of x dx, and the integral from 0 to 5, 3 f of x dx. Go ahead and pause the video, copy these down, and see if you can get the answers, and then I'll come back and share those answers with you in a few minutes. So here are the answers. With this one, it went from 0 to 7. These intervals go from 0 to 5 and then 5 to 7. So I can separate this out and go from 0 to 5 to 5 to 7, and then force them to look just like what they gave me. So I've got a 10 plus 3 to give me 13. In this one, my big number was on top, so I have to flip them. When I flip them, I put a negative in front, and that makes it look just like this, so it would be a negative 10. And for this one, I have to bring the 3 out to the front 3 times. This one looks exactly like this one, so 3 times 10 would be a 30.